What's up guys, welcome back to the channel. In a previous video tutorial, we have discussed a very important question regarding to the binary trees, and that question is basically find the height of a binary tree. So if you have not watched that video, I'm making all the important questions and all the concepts of a binary tree in a series. So make sure you are watching these videos in a series. So make sure you have also accessed or bookmarked the series of the Shivaya's tree series. So in this video tutorial, we are going to solve another most important question of the binary trees related to the binary trees, which is basically a level order traversal. So what is a level order traversal is? So let us suppose I having a binary tree. Let me create a binary tree. So this I am creating a binary tree. This is the first node. Let's say it having a left children 2 and let's say it having a right children 3 and the left children of 2 is a 4 and the right children of a 2 is a 5 and the left children of a 3 is a 6 and the right children of a 3 is a 7. So let us see what is level order traversal actually is. So let me write here level order traversal, which we are going to discuss in today's video with a code also. So level order traversal. Clear? So I am writing TR only. So when we talk about the level order traversal, as its name specifies, it is a level order traversal. So what we will do, level wise we will print all the nodes. So if I say this is my level 1, this is my level 2, this is my second level, and this is my third level. So what I will do, level wise I will print all the nodes and that will be my level order traversal. I will repeat again that what is a level order traversal? When I have given a binary tree and I print the nodes present in each level one by one, starting from the topmost level to the last level, and all the nodes in the levels will be from the left to right. That thing will be the level order traversal. So if I talk about the level order traversal of this tree, first I will go to the level 1, and what are the first node? That is only 1, so I will simply write it into the answer. Then I go to level 2 because there is no more node present in the level 1, so I will go from left to right. Okay, I will go from left to right. So what is the node present on the level 2? That is a 2, so simply add it to the answer. And what is the next node to the 2? That is a 3, simply add it to the answer. Now go to level 3 because there is no more node present in the level 2, so level 2 is completed. So now we move to the level 3. So what is the first node? That is a 4, simply add 4 to the answer. And what is the next node to this level? That is a 5, so I will simply add 5 to the answer. And then I have in the 6 and 7. So as you can see, after 7 there is no more node present in this level which we have not taken in our traversal. So we have taken all the nodes. So if you carefully see, this is a level order traversal of a tree. So first of all we start from the left to right for each and every level. So this level is taken 1 and then 2, then 3, then 4, then 5, then 6 and then 7. So can I say the level order traversal of this tree is this particular one? 1, 2, 3, 4, 5, 6 and 7. Now we will see how to get the level order traversal of any tree. What mechanism we will use. So let me erase all this stuff to clear the concept of the level order traversal for you. So how to find out the level order traversal? So simply the technique is very easy. So this we are using a queue data structure. So we are using a queue data structure. We are using a queue data structure in order to find the level order traversal of a given binary tree. So how the queue data structure is used in order to calculate the level order traversal, let us see. So we will take a queue of a node type. So what we will do, we will take a queue. So if you don't understand what is the queue data structure, so make sure you have watched the videos regarding queue data structures. I'm not saying that it's present on my channel, but you can go through the queue data structure and then come to this video, because if you don't understand what is the queue data structure, then it is not possible for you to understand how the level order traversal works. So what I will do, let us see. First of all, to find out the level order traversal, let me explain first of all a queue data structure. So queue data structure works on the first in first out mechanism. First in first out mechanism means, suppose we have inserted 1 into the queue, and then we have inserted 2 into the queue, and then we have inserted 3 into the queue. Now when we perform a deletion operation, the element which is inserted first will be deleted. It means first in first out. So the element which is inserted first will be deleted first. As you know, the 1 is inserted first, so 1 will be deleted first, then 2 and 3 will be left. In between these two, the 2 will be deleted because it is inserted first from the 3. So this is how the queue data structure works. So let us see how we will be solving this question. First of all, we will take a queue. So this is our queue. Let me write as a queue. We will start from the root node. As I have cleared that every type of a traversal we are starting, we will always start from the root node. So we will start from a root node. What we will do, we will simply push the root node into the queue. So let us add the root node into the queue. Clear? So after adding a root node into the queue, I will see until my queue is not empty. So I will repeat a process until my queue is not empty. So means until there is any element present in my queue, I will continuously do this process which I am showing to you. So when my queue become empty means my traversal is completed. I will again repeat that. When my traversal is completed, when my queue is empty, then my traversal is completed. So let us see what I will do. I have taken a node 1 and simply push it into the queue. After pushing into the queue, I will see. So here if you carefully see, what is the front pointer pointing to? As we know that the front always point to that particular element which is present in the front of the queue, which is inserted first time, and rear is always pointing to that element which is inserted last time. So here our front will be pointing to this one. So we will continue do this process which I am repeating. We will take the node which is pointed by the front. So which node is pointed by the front? Which is a 1. So we will simply add 1 to the answer. So let us add 1 to the answer. After adding 1 to the answer, what we will do? We will check, is there any left children of this 1? As you can see, the left children of a 1 is a 2. So if its left children is present, so what we will do? We will simply push it into the queue. So let us push it into the queue. And then we will check the element which is present on the front of the queue. We have taken its left children, that is a 2. So now we will check, is its right children present? Yes, its right children is present. As you can see, its right children is a 3. So we will simply add this 3 into the queue. As you can see, so I have simply added this 3 into the queue. So now we have taken this 1 into the answer. As you can see, also we have taken its left children into the queue and its right children into the queue. Now what we will do is, we will simply pop this. So we will simply pop this 1. So popping this 1 means, when I pop this 1, it will be like this. So let me clear the concept. So when I pop this 1, it will be deleted. So let me explain. So when I pop this 1, this will be deleted, and when this 1 is deleted, so our front will be pointing to what? Our front will be pointing to now this node. So front, instead of this, now pointing to what? Front is pointing to this 2, if you carefully see. So now our front is pointing to what? Our front is pointing to this 2. So can I say my front is pointing to this 2 now instead of this 1? So now my front is pointing to the 2. So what I will do, I will again repeat the same process. And what is the process? Until my queue is not empty. When my queue will be empty, I will stop this process. Until what I will do, the element which is on the front of the queue, I will take it and write it to the answer. So in the front of the queue I having a 2. So simply take this 2 and write it in the answer. After writing it into the answer, see, is there any left children of this 2? Yes, it having a left children, that is a 4. So simply push it into the queue. Again see, is it any right children of this 2? Yes, there is a right children of this 2, that is a 5. So simply push it into the queue, that is a 5. One thing you need to remember, that we are simply taking the front element of a queue, we adding it to the answer, and if its left and right children exist, we pushing it into the queue. And after this, doing this stuff, because we have taken this 2 and also we have taken its left and right children. So now what we will do, we will simply pop this. So simply pop means we will simply delete this. Okay, so after deleting this element will be deleted from the queue. So now our front pointer will be pointing to what? So our front pointer will be pointing to the 3. Clear? Again we will do the same step. We will take the front element of the queue and add it to the answer, and we will see, is there any left children of the 3, or is there any left children of the front element of the queue? Yes it is, that is the 6. So simply add 6 to the queue, and then we will see, is there any right children of this 3? Yes there is 7. Simply add it to the queue. After we have taken the front element of the queue into the answer and also taken its left and right children, what we will do, we will simply delete this element from the queue. So we will simply delete this element from the queue. So when this element is deleted, this will be like this particular one, and the front will be pointing to what? Now the front will be pointing to, so the front will be pointing to what? So our front will be pointing to now this 4, because our queue is not empty. So we will again take a front element and add it to the answer. So let us take this 4 and add it to the answer, and now we will see, is there any left children of this 4? No, there is no left children of the 4, because in the left field of a 4 we are having a null. So is there any right children of a 4? No, there is no right children of a 4. So we will not add it into the queue. So what we will do simply is, we need to just pop it. So after popping it, again this element will be deleted, and the front will be pointing to what? The front will be pointing to this element. So our front will be pointing to this 5. Again for the 5, I will check, first of all I will take this 5 into the answer. So let us take, because every time first step I need to do is, the element which is pointed by the front pointer in the queue will be added to the answer. So let us add this 5 to the answer. Then we need to see, is there any left children present for this 5? No, there is no left children for this 5. Is there any right children for this 5? No, there is no right children. So we cannot add it into the queue, obviously, because there is a null. So after doing this stuff, we will simply delete this element from the queue, and after deleting this element from the queue, this element will be deleted, and the front again will be pointing to what? The front will be pointing to the 6. Again what will happen? We are having a 6 on the front of the queue. So what we will do, whatever in the front of the queue, we will simply add it to the answer first of all. So let us add it into the answer. After adding it to the answer, we will check, is there any left children for this 6? No, there is no left children and right children for this 6. It is a leaf node basically. So what we will do, we will simply remove this. So we will simply remove this from the queue, and now the front will be pointing to what? The front will be pointing to the 7. So I can say that our front is pointing to now 7. Again for the 7, if you carefully see, whatever in the front of the queue, first of all we need to add it to the answer. So let us add 7 to the answer, and then we will see, is there any left or right children? If the left children is present, then push it into the queue, and if the right children is present, then push it into the queue. But as you can see that there is no left or right children present. So what we will do, we will simply pop this element. So pop this element means there is nothing present in the queue. So our queue will be like, there is nothing present here and there is nothing present here. So front is pointing to what? Nothing. So front is not pointing to anything. So now we can see that our queue becomes empty. So when our queue becomes empty, there is no element is present in the queue. Queue is completely empty. It means that it is a base condition. We have gotten our traversal. If you can see, we have gotten our level order traversal 1, 2, 3, 4, 5, 6 and 7. So this is the how we can find out the level order traversal. So what is the intuition behind this? So if you carefully see, we have taken the first node. After taking this first node to the traversal, we are always checking what is its left children and what is its right children. So first priority we will give to its left children, and as we know that the queue data structure works on the principle of a first in first out. So first 2 comes. So first of all we move to the 2 for each and every node which is present in the front of the queue. First of all we taking that node and adding it to the answer, and then we are seeing is its left or right children present. If its left or right children is present, then we simply push into the queue. After doing this step, whatever is on the front of the queue, we will simply pop it out, and we will do this continuously until our queue becomes empty. So this is how we can calculate the level order traversal of a binary tree. So let us move to the code part. Let us see how its code works. So as you can see here, first of all we have basically specified the node structure, in which having a data field, one left and a right field for storing the address of a left node and for storing the address of a right node. So this is the structure of a node. And here we having a create function, in which we having created a node. Here we having a label order traversal function, in which you can see that we are passing a root node in order to found the label order traversal. So first of all, the create function will create a binary tree, as you can see, and then here what the label order traversal code is. So first of all, we have taken a queue of type node, so it will be storing a nodes. Clear? We have taken a queue, and in this queue, first of all, we have pushed the root node. Clear? We are first of all creating a tree, and then we are calling a label order traversal function, in which we are passing a root node address. So we are initially passing the address of this node. Clear? So after that, what we have done, we have created a queue of node types. So we have pushed the first root node into the queue. Here we have pushed the root node into the queue, and the condition is until the queue is not empty. So I can say while the queue is not empty. While the queue is not empty, what we will do, whatever present on the front of the queue, we will take it temporarily in the node variable, and after that print the data of that node and simply pop it. And after popping it, we will check, is there any left children present? Yes, its left children is present. So if its left children is present, we will simply push into the queue, and then we check, is its right children is present? If it is present, then we simply push it into the queue. So we are doing this process continuously until our queue become empty. So for each and every iteration, whatever present in the front of the queue, we will simply print it out, and after printing we are deleting it, and after deleting it we are checking, is its left children present or is its right children present? If it is present, we are pushing it into the queue. So finally in this way we are getting the traversal. So let us move to the input part. If you carefully see what is the input is, first of all we are having a root node as a 1. So let me explain here. So we are having a root node as a 1. Clear? This root node having a left children as a 2. So it having a left children 2, and then the left children of 2 is nothing. So I can say that there is nothing present in the left of this, and the right children of 2 is a 6. Clear? And after that, left and right children of 6 is nothing. So there is nothing. Here will be null, here will also a null, here will also a null. After that we are having a right children of a 1, which is a 3, and the left children of a 3 is a 4, and there is no left and right children of this 4. So there is nothing, and the right children of a 3 is 5. So here will be 5, and there is no left and right children for this. So here is a null. So if we talk about the label order traversal of this, first we will take this 1, then we will take this 2, then this 3, then we will take, this is a null because there is nothing present, so obviously we will not take it. Then we will take 6, 4 and then 5. So 6, 4 and 5 will be the answer. So as you can see, 1, 2, 3, 6, 4 and 5 is in the answer. If I again run it by saving, so if you can see, the answer is 1, 2, 3, 6, 5, 4. So I hope you understand the concept of a label order traversal. In the next video, we will be discussing about the diameter of a tree and the most interview asked questions regarding a tree data structure. So make sure you are subscribed to our channel or also press the bell icon. So see you next video. Till then, bye bye.